We are on a crash course in common plunge towards our adjoining enormous universe, Andromeda. Likewise, an arrangement of a few 100 billion stars, our grandiose neighbor, the Andromeda cosmic system, is the closest winding system to the smooth way. What's more, it is supposed to crash into our world. This occasion isn't supposed to occur for another 4 billion years. However, a stunning sign has been sent back to Earth by the James Webb Space Telescope, showing that the impact will happen far sooner than anticipated. After following 100 years of presumptions, the information from the James Webb Space Telescope has changed our understanding of the Andromeda cosmic system by uncovering frightening and startling insights about its true essence. This revelation has ignited a whirlwind of fervor and speculation within the academic community. Is this a response to our efforts at interstellar correspondence, or does it indicate a divine event that is still obscure? And what happens when Andromeda strikes Earth in the smooth way? Join us today as we explore the explanation for the disturbing signal received by the James Webb Telescope from the Andromeda universe. Our cosmic system, the smooth way, belongs to the local group of worlds and is a bee-twisting world. To track down this system, you would have to gaze toward the night sky toward the star heavenly body Sagittarius. Its cosmic center is faintly apparent there. All stars, in any case, are part of the smooth way and are visible to the unaided eye from Earth. The rotational speed of the smooth way is similarly quicker than that of many other cosmic systems. Despite the fact that there are billions of cosmic systems in the universe, this one has taken an cosmically long opportunity to uncover and comprehend due to the limited logical instruments available at the time. Astronomers initially knew very little about the smooth way. The first recorded observations of the smooth way date back to ancient civilizations. The Greeks named it Galaxia, meaning smooth circle, because of its smooth appearance in the night sky. However, it was only after the development of the telescope that we began to understand its true nature. With the creation of the telescope in the mid-17th century, cosmologists like Galileo Galilei were able to see that the smooth way was made up of a huge number of stars. This was a huge step towards figuring out the construction of our cosmic system. In the mid-20th century, the idea of the twisting nebulae was the subject of a great debate between Harlow Shapley and Herbert Curtis. Shapley contended that the smooth way was the whole universe, while Curtis believed that the universe comprised various cosmic systems like the smooth way. The discussion was settled by Edwin Hubble during the 1920s, when he identified Cepheid variable stars in the Andromeda universe, which allowed him to demonstrate that it was indeed an independent cosmic system outside the smooth way. Edwin Hubble's work on the Andromeda world also led to one of the most significant discoveries in modern cosmology, the expansion of the universe. By observing the redshift of the light from the Andromeda universe, Hubble was able to show that the universe is expanding, with systems moving away from one another. This discovery formed the basis of the Big Bang hypothesis. However, Hubble was not the first cosmologist to observe this system. Since ancient times, people have been aware of the Andromeda system. The Persian cosmologist Abd al-Rahman al-Sufi called Andromeda the Little Cloud in his Book of Fixed Stars in 964 AD. He was the first cosmologist to see Andromeda with the unaided eye, before the development of telescopes. However, it was only much later that its full nature as a cosmic system was recognized. Astronomers sometimes call the Andromeda world by the name M31 or Messier 31. For quite a while, space experts believed Andromeda to be considerably larger than our own smooth-way world. Recent investigation has led to a reassessment of these beliefs. Based on all suitable data, space experts estimate that Andromeda is about 10 billion years old, placing it in the early universe. Its age suggests that its development and evolution have had a long and complex history. Compared to the smooth way's 250 to 400 billion stars, Andromeda has around 1 trillion stars. Although it appears quiet to the unaided eye, space experts have discovered a savage history and future within it. One of the most interesting features of the Andromeda cosmic system is its dynamic cosmic core, known as an active galactic nucleus, AGN. The AGN is a highly dynamic region at a cosmic center, identified by strong emissions at a range of frequencies, including X-rays and radio waves. The supermassive black hole situated at the center of the system provides the energy hotspot for AGN. These supermassive black holes are incredibly dense regions in space with a huge mass compressed into a small volume. The supermassive black hole in the Andromeda cosmic system is estimated to be about 110 to 230 million times the mass of our Sun. According to estimates, these supermassive black holes, like the one in our Smooth Way, are frequently found at the centers of galaxies and significantly affect the dynamics and evolution of cosmic systems. An interesting hypothesis regarding Andromeda's formation suggests that it formed through the merger of various smaller protogalaxies. This implies that smaller galaxies gradually merged due to gravity over billions of years to become the magnificent Andromeda system that we see today. These types of galaxy mergers are frequent events in the universe, influencing the development and organization of galaxies. Recent observations and analysis by the James Webb Telescope have sparked speculation among space experts that the Andromeda cosmic system may be undergoing a significant transformation. The signal indicates a possible transition of the Andromeda Galaxy from a typical spiral galaxy to a ring galaxy with unique features. The James Webb Telescope has also found that the history of the Andromeda system is similar to that of the Smooth Way. Both cosmic systems have a single merger event that dominates their inner dynamics. According to researchers, the Smooth Way and Andromeda galaxies are headed for a collision and will ultimately merge to form a new supergalaxy. At present, the Andromeda cosmic system is moving at a speed of around 200 kilometers per second toward our Smooth Way. Considering this, our merger will take place in the next 4.5 billion years. However, evidence from the James Webb Telescope suggests that this interstellar crash could happen far sooner than previously believed. The main reason the Smooth Way and Andromeda will merge is that they became gravitationally bound to each other before dark energy took over. This colossal event has been nicknamed Melodromeda. Nonetheless, the effects of this merger would be catastrophic for human civilization. The gravitational forces of both galaxies will cause them to distort each other's shapes as they get closer. As black holes draw nearer together, the energy they release as gravitational waves becomes increasingly intense. These gravitational waves divert orbital energy, causing the black holes to gradually approach each other over time. The process of two black holes merging is a destructive event, releasing an enormous amount of energy into the surrounding space. This phenomenon, known as a black hole merger, is one of the most powerful events in the universe. When black holes merge, they create ripples in the fabric of space-time, known as gravitational waves, spreads outward from the blending black holes, diverting energy from the framework. As the black holes lose energy, they draw nearer together, eventually converging into a solitary, more massive black hole. The consolidation of two black holes can have significant implications for the surrounding environment. Sometimes, the gas and other material surrounding the black holes can be brought into the consolidation, forming an accretion disk around the newly formed black hole. The accretion disk can create intense radiation across the electromagnetic spectrum, including X-rays and radio waves. The mix of gravitational waves and electromagnetic radiation created by a black hole consolidation makes these events some of the most vibrant phenomena in the universe. One potential result of a black hole consolidation is the formation of an active galactic nucleus, AGN. An AGN is a highly luminous region at the center of a galaxy, powered by the growth of material onto a very massive black hole. The energy released by the AGN can surpass the combined light of all the stars in the galaxy, making it one of the brightest objects in the universe. The creation of an AGN through a black hole consolidation can have extensive consequences for the surrounding galaxy. The intense radiation and energy produced by the AGN can heat and ionize the surrounding gas, triggering star formation and influencing the evolution of the universe. AGNs are believed to play a crucial role in regulating the growth of galaxies and shaping their properties over infinite time. The consolidation of two very massive black holes can also produce gravitational waves powerful enough to be detected by observatories on Earth. In recent years, gravitational wave detectors like LIGO and Virgo have made pivotal detections of black hole consolidations, providing astronomers with new insights into the nature of these complex objects. Studying black hole consolidations can also shed light on the evolution and development of galaxies. Very large black holes are thought to reside at the centers of most galaxies, and their consolidations may play a significant role in shaping the properties of galaxies over infinite time. By examining the properties of merging black holes and their host galaxies, astronomers can gain valuable insights into the processes driving galaxy evolution. In addition to their scientific importance, black hole consolidations are also fascinating objects of study in their own right. These astronomical crashes represent some of the most extreme events in the universe, where the laws of physics are pushed to their limits. By studying black hole consolidations, cosmologists can test the predictions of general relativity and other fundamental theories of physics under the most extreme conditions possible. Overall, the consolidation of black holes represents a critical process in the evolution of galaxies and the universe as a whole. These cataclysmic events release immense amounts of energy and produce gravitational waves that can be detected across the universe. As we ponder the fate of our solar system in the event of a cosmic merger, it is essential to consider the significant ramifications of such a vast impact. The merger of the Milky Way and Andromeda galaxies will undoubtedly reshape the structure and dynamics of our cosmic neighborhood, with far-reaching implications for our own solar system. One of the most critical impacts of a cosmic merger on our solar system is the possible disturbance of its orbit within the newly formed galaxy. Currently, the solar system resides in a relatively stable orbit within the Milky Way, situated in a branch of the galaxy known as the Orion Arm. However, in a merged galaxy, the gravitational forces acting on the solar system could significantly alter its trajectory. According to current computations, there is a 50% likelihood that the solar system will be swept out multiple times farther from the galactic center in the merged galaxy than it is currently. This means that our solar system could find itself much farther from the center of the galaxy, potentially leading to enormous changes in its environment. Moreover, the ramifications of such a dramatic change in the solar system's position within the galaxy are significant. The distribution of stars, gas, and other material in the galaxy will be altered, possibly disrupting the fragile equilibrium that has allowed life to flourish on Earth. The radiation environment, prevalence of supernovae, and other cosmic phenomena could all change, with unknown implications for the habitability of our planet. Additionally, the interactions between the solar system and other stars and planetary systems in the merged galaxy could lead to gravitational disturbances, perturbations in orbital elements, and even close encounters with other celestial bodies. While it's unlikely that any stars or planets will collide directly, the gravitational interactions between neighboring systems could have profound consequences for the stability and evolution of the solar system. In addition to changes in its cosmic environment, the merger of the Milky Way and Andromeda galaxies could also affect the long-term evolution of the solar system itself. The increased gravitational forces and tidal interactions resulting from the merger could destabilize the orbits of planets, moons, and other objects within the solar system, potentially leading to orbital revisions and possibly even ejections of bodies into interstellar space. Furthermore, the merger could trigger a period of enhanced star formation and activity within the newly formed galaxy, resulting in an increase in the number of supernovae, gamma-ray bursts, and other energetic events. While these phenomena are unlikely to directly impact the solar system, they could contribute to changes in the cosmic environment and radiation levels experienced by Earth and its inhabitants. Overall, the future of our solar system in a merged galaxy is uncertain and complex. While current estimates suggest that the solar system might be swept out farther from the galactic center, the full extent of the changes and their implications for life on Earth remain to be understood. As we continue to study cosmic mergers and their effects, we gain valuable insights into the dynamics of the universe and our place within it. The Sun is located in a part of our galaxy known as the Orion Arm. Our galaxy is divided into spiral arms, and our solar system would be right at this arm's fingertips. If we were sent farther away, researchers estimate that there is a 12% likelihood that the solar system might be completely ejected from the newly formed galaxy at some point during the merger. What about life on Earth, then? Will life on the planet continue after the merger? Well, in approximately 7.5 billion years, the sun will become larger and swallow the Earth, transforming it into a red giant. However, the sun's inherent brightness will rise even before then. This will happen eventually in a timeline of about 4 billion years. As solar radiation reaching the Earth increases, Earth's surface temperature will rise, and we could experience a runaway greenhouse effect similar to what's happening right now on Venus, the planet next door. Therefore, there's a good chance that life on Earth won't exist after the merger. However, by that time, perhaps some people on Earth will have developed space travel. The fact that we will makes it conceivable that we could have abandoned Earth in our solar system. The view of Andromeda slamming into the Milky Way could still be accessible to us, albeit from a somewhat different perspective.